Hello everyone, for this tutorial video I'd like to talk about two-dimensional integrals called double integrals. Not only because of the two dimensions, but also because the computation will involve two integrals at the same time, as we will see. We first recall that for a one-dimensional integral from Calculus 1, we take the area under a function's curve to be a specific amount of rectangles whose length is given by a change in x, and whose height is given by an arbitrary value within this change in x. And then we take the limit as the number of rectangles approaches infinity and the length of each rectangle becomes infinitesimally small to get the actual area under the curve, which is the definite integral. We reiterate why this works, because double integrals have a very similar derivation. In particular, we say that a rectangular region has its length x bounded between 2 points, and its width y bounded between 2 points. And then we take an arbitrary value of the function within each rectangle, and take the limit as the number of rectangles under the 3D curve approaches infinity, and the cross-sectional area of each rectangle becomes infinitesimally small. This means we have two sums, one for the length and one for the width, instead of one sum like a single variable integral. And these sums both approach infinity at the same exact time. The conventional shorthand for a double integral is two integral symbols with an r beneath it to indicate a rectangular region. The integrand is f of x comma y, and the variable you're integrating with respect to is change in cross-sectional area. This logically means that just like the area under a one-dimensional curve is given by a single integral, the volume under a three-dimensional curve is given by a double integral. Now that we have first defined what the double integral is, we can discuss methods for computing actual values of it in the next video using a method known as iterated integrals.
Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.